Okay, good morning everybody.
Good morning.
Buenos días.
Buenos días.
Dobre utra. Swaha wana shen. So today we are going to review some concepts. In the past we studied about the fraction. Today I want to be sure that everybody is going to understand another word which is called equivalent fractions. Repeat after me, please. Equivalent
Fractions.
again. Equivalent fractions. After me. Okay? After me. First, I am going to say the word, and then you are going to repeat. Equivalent fractions.
Equivalent fractions.
Very good. The language objective here is going to be, we're going to learn about equivalent, when two equivalent fractions are and same, equal, and we're going to review the present tense, is and are. So also we are going to do some comparative adjective here, greater than, smaller than, and in social we are going to work in collaboration. Means we're going to do an activity today that is matching fractions. You're going to receive a set of cards and you're going to match those equivalent fractions. Okay? So, but first of all, we need to review the concept of a fraction. In the past, we say that the fraction, what I am missing here? A mathematical relationship between two numbers. A fraction is, so a fraction is a mathematical relationship, another important word in mathematics, between two numbers. Two numbers. So somebody remember this number here and this number here. How we call this number? How we call?
Numerator.
Everybody, how we call?
Numerator.
Numerator. Very good. Numerator. Very good. How we call this number? Denominator. For example, I am going to give you a numerical sample. So here is, for example, 2/5. Okay, 2/5. So 2 represent the numerator, right? Yes? And 5 represent the denominator, right? Okay, so now we are going to do, which is called the graphical representation. Okay? So we are going to pick up from here. Like this. And this is a whole, right? A whole, a complete whole. So my question to you is, in how many parts I need to divide the whole?
5.
How many?
5.
5. So the denominator indicate how many parts do we need to divide the whole, right? So I am going to pick my division tool here, and I am going to divide the shape for, very good. So everybody can see that the whole was divided in 1, 2, 3, 4, 5, right? Yes? So this is the division. But now, how many parts do we need to pick up to represent this one? 2. So I mean 1 and 2. So the yellow, what is this color?
Yellow.
Yellow, right? Like the sun, yellow, right? Okay, we have a beautiful sun today, right? It's cold or warm outside?
Cold.
Very cold today, right? But we have a spectacular sun, right? Okay, so how many parts here? 2 over 5. Very good. Any questions? No questions? So, we review the concept so far, which indicate the numerator, what does represent the denominator, and we did the graphical representation, right? No questions? So, for example, going to the next page, if I say, let's do 3 sevens. 3 sevens. So here I have my. So we are going to use now graphically another kind of representation. We use the pi. Now we are going to use the a bar. Okay. So let's do a bar like this, a chocolate bar. Do you like chocolate? Everybody likes chocolate, right? Okay, I know a guy that doesn't like chocolate. So, I don't know, sometimes. Okay, good. So, let me know in how many parts I am going to divide this. How many?
7.
7. So 7 is, how we call this number? How we call the number? Everybody. Everybody one time. Now, denominator. How we call this one?
Denominator.
Denominator. Very good. So I am going to select my object, and now we are going to divide by
7.
how many parts?
7.
Very good. 7. 7's there, right? Okay. So this number here, how we call this number? No, we're talking about the part of the fraction, not the number. Okay. So how we call this one? Numerator, right? Numerator. So I am going to do with same color, yellow. So how many parts? 1, 2, and 3. Right? So the cool thing about the smart board is also the possibility to differentiate dramatically the objects that I am working here. So I have clear that this one is 3 over 7. Okay? Very good. Next one. So we're going to move. For sure everybody understands this point, right? Okay. So let's work now with something that we studied before, but the word is this. Equivalent. Somebody can tell me what does mean equivalent? It's the same word in other language like Spanish, for example. In Spanish, Somebody can tell me how you say equivalent.
Equivalente.
How you say?
Equivalente.
Equivalente. So the same word. Right? So what does mean equivalent in English? The same. Exactly. The same. And take a look here, guys. So actually, the same is one of our words that we are going to study today. The same. The same. Another word to describe equivalent. Equal. Exactly. Same, equal. Right? So those are words that we are going to study in mathematics. Not actually here in numbers, discovering fractions. In the near future, we are going to study this one when two triangles are equal. The common core standards, the new standards, they are very precise about the words. Okay? And we are going to study, so if we learn now, then we are going to apply. Okay? Very good. So, equivalent, but talking about fractions, let me give you one fraction here, and you are going to, so you're going to give me your ideas. Okay? So let's say an easy one. 2 over 4. 2 over 4. So now 2 over 4, what can I do with this fraction? So what do you want to do? Simplify the fraction, right? So remember that we studied when we have factor numbers, right? So, okay, so you want to simplify by 2, very good, and you are going to simplify by 2, exactly, very good. So we are using here the trick in mathematics when we study simplification is dividing by the same number both numerator and denominator. Cristina Coruscant? So we are going to divide the same by the same number both the numerator and the denominator. So this is called simplification. It's another word, okay? So I will do in my parking lot here simplification. We will come back with this one and we're going to study this one. So 2 over 2 or 2 divided by 2 is 1. Fraction line 4 divided by 2 is 2. So can I say that 2/4 is equivalent to 1/2? Yes, they have the same value, right? So let's see if actually I am going to pick up these guys here and I am going to group this one. I'm going to do this one a little slow here. Let me see. Oops. Over there. This ones, and I'm going to group. So then can minimize this one, and we are going to represent 2/4. So 2 over 4 and 1/2. So let's do you want a pie or a chocolate bar? What do you want? Chocolate bar should be better? Okay, let's do 1 by 2/4. So I am going to do like this. And remember, if I need to compare two fractions, I need to compare same chocolate bars, right? Okay, so then I have to clone this one, clone, and I am going to do with this one. So how many parts I am going to divide this one? 4. So I am going to divide this one by 4. And I am going to divide this one by how many parts? 2. Very good. So then we are going to color. How many parts here in the first chocolate? 2. So 1 and 2. Right? So here how many parts I am going to
One.
Only 1. Right? So the idea of equivalent fractions is this. Take a look here. So I am going to pick up this 1/2 and I am going to pair here with 2/4. See? See over there? 2/4. How they are with 1/2? Equal. Right? So now I can add here the symbol equal. Right? Yes? So those are called equivalent fractions. So now we're going to do the activity. Okay? During the activity you are going to receive fractions, and the idea here is, take a look this poster here. So in this poster you are going to represent the fractions in your cards. Okay, so you are going to use some of those model here to represent those fractions. Which I want is, you're going to receive a family of cards, and working with those cards you're going to match. Okay, good? Very good. So we're going to do the activity now.